Ask children to draw a scientist and research shows that even today they're likely to portray someone old, male, wearing a white coat and pebble glasses, the ultimate nerdy professor. Science is still often perceived as hard, difficult, even boring. But one teacher is on a mission to bring science alive through practical work.
My name's Sally Crowe and I'm employed as the science coordinator. I'm also an advanced skills teacher in science. I'm a very big fan of practical work in science. I think it's essential for engaging the children and for actually moving their learning forward. Children actually really enjoy practical science and so they want to do it. They are enthusiastic. So it's all about channeling that enthusiasm in a productive manner. I will be teaching a Year 4 class of 30 children. This isn't my usual class. Their teacher is on school journey. This morning we're going to be finishing off a unit of study the children have been doing on solids, liquids and gases. So we're going to be looking at a mixture of different solids and investigating how we could separate those solids out from one another. Now first of all we're going to play a little our science equipment game. I've put some new equipment in here. OK, if you've got a really good question, show me you have a really good question.
Can you measure with it?
No.
Is it hard?
Yes.
Is it flexible?
Parts of it are flexible.
Does it use force?
No.
Has it got a spring in it?
No. Good question.
Does it have any holes in it?
Yes, it does have holes. That's a really big clue.
Is it a sieve?
It is a sieve. Well done. And a sieve might help us today with our investigation. In science lessons, I like to have the children in mixed ability groups, and we call them our science teams. So they're named after different scientists. Who can remember their team name?
Marie Curie, Charles Darwin, Faraday, Galileo, Albert Einstein.
And the children work within those teams. So, for example, I would have 5 or 6 children to a team, and they're all assigned a different job, and they can decide their jobs amongst themselves. So they work as a team challenge to encourage cooperation and discussion as well amongst the group to solve their problem. Now, we're going to be doing some science today, and we're going to be thinking about solids, liquids and gases. And we're going to be thinking about separating some solids. On your table, teams, you've got a pot with all sorts of different things mixed up in it. And I've got a little challenge for you. What I want you to do is see if you can find out what's in this, but without pouring it out onto the table. So the first thing you're going to do is use your observation skills, use your eyes. So they worked on their tables in their individual teams, how they could separate these items. We had lots of discussion and used our observation skills to really look carefully at what solids were in that pot.
We found seeds.
Seeds?
We saw a nail in ours.
I find a lot of teachers struggle with resourcing. So scientific equipment has the connotation that it will be expensive and difficult to find. But there are so many experiments at Key Stage 1 and Key Stage 2 level, today's for example, where all the equipment can be bought in your local supermarket. It's nothing that's requiring a specialist knowledge or even specialist equipment. What was our challenge to do with our pot of all our solids mixed together? What challenge did we have?
We had to separate all the ingredients from our pots.
Excellent, we've got to separate everything out. So I want you to decide how you're going to separate them and what equipment you're going to use, and then I'm going to be asking you to tell us, OK?
The sieve can take away junky and the magnet can take the paper clips. We can do the rice and sequins by maybe just using the spoon and taking them out. Then we can sieve the sugar and sand. And then dip the sand out. Yeah.
The equipment is waiting to be used, but Sally has a cool way to ensure there isn't a free-for-all. She's organising team members to do different jobs.
Tell me one of the roles that we have.
Tester.
Well done. Who could think of another one?
Equipment.
Well done. What else did we have?
A recorder.
Excellent.
A communicator.
Well done. Harry?
We have people manager.
People manager. Now, when we're doing our science, why do we have a different role to play? Why do we all have a job?
So not all of us are like rushing to get the equipment, and not all of us are bossing each other about, and not everyone's like fighting over who's going to do the writing. So it's all organised and everyone's happy with their jobs.
Lovely. What a lovely answer, Naina. Thank you. So you're right. And also, I know what you're doing and I know what you should be doing. How do I know which role you're playing?
Because we've got badges.
Yeah, you wear a badge. I've put some equipment out on the equipment table, but I haven't said that you have to have certain bits. I'm going to let you have a little bit of a choosing time. So, equipment people, are you ready? I'm going to give you about 10-15 minutes just to start separating some of these things out. Well, practical work poses a lot of risks because you've got all this potential for children to be moving around the classroom a lot. There's lots of equipment out that could get damaged, spilt, spoiled, and I can really understand that there's quite a pressure and a fear to keep the children in one place controlled, whereas obviously with practical work it opens up a lot of opportunities for misbehaviour, for not concentrating and for being off task.
No, we haven't actually separated it yet.
I was most pleased with the children who noticed that when they would separate the sequins and the paper clips and the paper fasteners and they were just left with the sand and the sugar, that if they used a sieve, the sand and the sugar were both going to go through the sieve. OK, do you know, I am really impressed, scientists, very impressed. We've got all these different bits and pieces separated out. I can see paper clips, yep. Marbles, yep. We've got some split pins there. You were asking for a smaller sieve, Jack. Why did you want to have a smaller sieve?
Because I know that a grain of salt or sugar is a bit bigger than a grain of sand. So if there was a smaller sieve, then the sand would go through and the salt would stay in.
What an excellent scientific observation there, Jack. Well done. Because a lot of you noticed that both the sugar and the sand in your mixture were going through the sieve. Now, I'll let you into a secret. It is sugar in your mixture. I love teaching science because I find that the children really engage with it and it gets them moving and thinking in a totally different way. I think it's an incredibly exciting subject, but I'm not a trained scientist myself. It's just that I have particularly developed this area of my teaching. We've got our rice, got our sequins, paper clips, marbles, but now we're going to have to get our sand and our sugar out of our mixture. We're going to have to separate those two. Sebastian's team. Sebastian, can you tell us your idea for separating the sand and the sugar?
We didn't have an idea for separating them, really, except for a smaller sieve.
Do you know, I think actually that's a really interesting point because over on that team I heard them say earlier as well, well, we can't separate them. They're just stuck together because we haven't got a smaller sieve. So we can't separate them. And I'm really, really quite pleased that some people are a bit stumped by this, because the thing I love most about science is that it doesn't matter if you get the answers wrong. All right? Really, with science, as I try and get across to my children, that you find out more from when you don't know the answer. If you already know what you're doing before you start, then you just prove yourself right. But if you're completely wrong in your predictions and your theories, then you find out something new. So everyone's a winner, really. I'm going to give you some more pieces of equipment now. Who could tell me what this is called?
Is it a funnel?
It is a funnel, well done. Does anybody know what this piece of equipment is? What do you think it might be, Azair?
thick paper?
Ooh, excellent answer. It is a type of paper, and this is a special science paper called filter paper, and we use it to separate things. Okay, so have a little think about that. Now, your last bit of equipment you're going to need for this investigation, you're going to need your beaker, a funnel, some filter paper, and some water. Water is a really big clue. I saw some people around there going like, ah. That's the lights on moment, isn't it? Here's what I'd like you to do with your filter paper. I'd like you to fold it in half like that. When you've done that, I want you to fold it in half again. And we're going to pinch these two middle bits inside like this, and then when we pull it out, we can make a nice little pocket like this. And then we're going to pop this inside our funnel like that. Where do you think we're going to pour our sandy, sugary water? Where do you think we're going to pour it?
Are we going to pour it just in the middle of here?
That's exactly right. When you've done that, you're going to pour it just in the middle through here. I think it doesn't matter how long you've been teaching, you still get that buzz when the children get that buzz. And you can get that through teaching practical science and letting the children get involved. You get those moments where the kids come in, they're fired up, they're excited. And as a teacher, we do want that in our classes. We do want to feed off that enthusiasm of the children. Okay, so we've got most of our solution of sugar and water. We put it through our filter, so we're left with the sand in the filter paper. Now, I've asked some tables to think about how they would get the sugar back out of the water. This table had a really interesting idea, which I would like them to tell you about.
We thought that you might be able to freeze it, because sometimes when you freeze a liquid, it turns into a solid.
This sort of lesson is really handy for showing up misconceptions in children's understanding. For example, talking about separating the sugar and the water, some of the children suggested that you would freeze this solution because they knew that freezing made a liquid into a solid. So they figured if we freeze it, we'll end up with sugar again. Did anyone come up with another idea about how to get that sugar out of the water?
You can heat it.
What would heating it do to the liquid, Aaron?
Maybe it would evaporate it.
What does it mean if a liquid evaporates?
It means that a liquid turns into a gas.
Excellent. So if we evaporate the water, if we turn it into a gas, what do you think is going to happen to the sugar?
Will it be left on its own?
It will be. Excellent. Well done. So we can separate our sugar from our water by evaporating the water, okay? So that we're left with just the sugar. Now, who can spot a good place in the classroom and they could point to it to show us a good place to leave water to dry up? My message to teachers would be just to really give practical science a go. It may seem like it's going to be scary and that the class might not be doing quite what you expect, but really the benefits to the children are enormous and it's actually really good fun to the teacher, so be brave and give it a go.